what is the gross sand thickness across this log section?
Okay, so let me attempt to answer that. Now, you know, I also recognize that unlike when I was doing it in the slides, you couldn't print the log out physically, you know. So you were doing a lot of visual, you're doing a lot of evaluation visually, but still fair enough. Okay, so let's do this. Okay. So let me draw this line.
Okay.
Sorry, my lines are not perfect, but I'll correct them as. So let me. Should even be able to put a line. Okay, draw a line. Yes, okay, I can get a line. Great. Then I hope you are following it.
Yes, sir.
So this one actually should. Then, even though at least this particular, okay, probably let me take this line, not two. It's just so if you have then, so I'm putting in the line. Neutron, there is. Apologies for. Now, so let me now. So you have. Oh, okay. So let's look at it. So you have sand. So you see how, and that's why I drew the lines across. Because you use both the gamma ray and the neutron density for sand delineation. You're looking at the portions for which the neutron trends to the right of your density.
Okay.
So here, so there's about, each box is 2 feet, isn't it? Each box is 2 feet. Each box is 2 feet. So you have about probably 3 feet from the top of the sand to somewhere there. There's a foot, which you discounted as. It's very short, it's very small. Let me draw that line. There's a foot somewhere here. I mean, if I'm trying to be exact, just going by the neutron density, but from the gamma ray it's thick, so I can discountenance it. So if you are looking at this, you are looking at from here. So if I take it this way, the top of this sand is at what depth? 6.2. We can take it to be 623, isn't it?
Yes.
We can take roughly. We can take the top of the sand to be 623 meters, thereabout. And then if I come here, I can
655.
655, isn't it?
Yeah.
It's below 655, but roughly, let's look at that. It's about 656 if you look at it, but thereabout. So if you subtract this, now there's also a small portion between 65. This is 655, 657, 659,
659.
661.
Six
I think
one.
6.1 to 6.63 thereabout. There's 2 feet of
6.3.
sand. Yes. So, but
Yeah.
if you subtract this 655 minus 623, that gives you 32, isn't it? Then you add another 2 feet. That's 34 feet. Is it clear?
Okay. Yeah.
Is it clear? So that's why the question was gross sand thickness across the log. And even in my answers, I made allowance for 632, 63. I actually made allowance for it. Is L'Oreal there? Oh, let me ask her to unmute. She won't be able to do that. Participants. Let me look for L'Oreal. So L'Oreal, you can unmute.
Yes, I have, sir.
So have you been able to follow what I did now?
I got lost at a point, sir.
Okay, which point?
Okay, I figured out you were using the density neutron log to find the
Yes, okay.
sandstone.
So you see what happens
So
is okay, sorry, continue, huh? Continue, L'Oreal.
No, you can continue, sir. You can continue.
Okay, so what happens is that.
Okay, so
continue.
Okay, so I think I noticed that you took out the parts that's above like the shaly parts.
Yes,
of the density
yes.
that was around
You have
that.
to take out the shaly parts. Yes, you have to take out the shaly parts. But I hope that's clear to you. I'll be clear to you
So the
now.
shaly part. I'm still asking a question, sir. So the shaly parts, if you're taking from that region, is about only 2 shaly parts, sir. So you subtracted those 2 parts
there's
out
shale,
of it.
clear shale from 656 to 6. This is 657.
655 to 661.
Yes, there is clear shale between 65 below 655 and 661. Then there is also, now if you look at, there's a portion below 66 from 6 between 663 and 664 that looks like sand. But if you go to the corresponding neutron density, you will see that the density trends to the right of the neutron. Okay, so I'll get back to you. So if we go strictly, we will discountenance that portion. Even though different things may be responsible for that, but strictly, even though I won't penalize you for 1 foot or thereabout. So, and of course, there's no sand below 664. From 664 downwards is all shale.
Yeah.
Now, one other thing, since we are talking about this now, okay. So, L'Oreal, I hope you have a good understanding now, a better understanding now.
Okay, what I just figured out was that you use the density neutron log to find the thickness of sand, not the gamma ray.
Even if I do not use the neutron density, the difference between the sand thickness, gross thickness, will not be probably more than 1 foot or 2 feet. Because, okay, let me clean this. Let me clean the lines. L'Oreal, stay with me.
Yeah, I'm with
you, that's why we're having this. That's why we're having this. So first of all, can you see I'm drawing? Do you agree this is the top of sand?
Yes, sir.
Great. So you might argue, though you go and then for this particular sand, this is the bottom of the sand.
Yes, sir.
Now, you know that there's a portion from between 6.3. So, but here and here, there's about 2 feet, which is shale.
Yes, sir.
So even if we use the gamma ray, this is about 656 to 656 minus 623. And even if you remove the 2 feet, that's from between this interval. Then you now come here again. There's a sand here.
Yeah,
and there's a sand here. I mean, there's a sand within this interval.
Yes, sir.
Even though it is shaly. So if we really want to be exact, this second line is not, this second line is actually from here. Let me draw the sand here. So the line is somewhere here. It's actually somewhere here. But if we go by, I've omitted a step. So let me just use this opportunity to do that. One of the things I asked for, you are going to do the gamma ray sand, isn't it?
Yes, sir.
Yeah.
So this is the gamma ray sand. Okay, I'll move it. You see, because the upper sand appears so if we do the gamma ray sand, note I intentionally didn't use this. There's a spike at 634,
6, 3.
So
6, 3,
even if you put your line at using this maximum here, it will still take the gamma ray value here to about 25. 25, 26, 27, there. I made allowance for that in my test. The trickier one was the shale. I think that's where so for the shale, okay, let me clean some of these things. I think it's making my screen,
easy.
So for the shale, you will use, this is the modal value. Sorry, let me do this. Draw the line. So now, something like this is actually the shale value. I think if I had the allowance, I'll move it a bit to the left, a little bit to the left. That's the modal value. You see that there are even some portions of the shale value which are outside the scale.
Yes, sir.
So that is why you don't go about using the maximum shale value. Note that logging, most of these readings are also statistical. So you use the modal value. This is what I was trying to explain as the modal value. So, and that is why I think in the answers, I think you see maybe about 93 or 90 or 90. I think 90, I can't remember exactly what it was. 90. But the whole idea is that by the time you find the V shale cutoff at 50%, it will take you to about 60, 57 or 60 thereabout. And the whole idea was so that this we'll be able to discountenance this portion. Let me draw this line. So that your cutoff is somewhere here. So the whole idea is so that the lower portions below 667 are all shale. So that there will be little or no dispute over the portion below 667. And everything else to the left is going to be sand. That's the essence of actually having the cutoff value. And every other thing there will be counted as shale. Okay. I think, let me see whether I have any raised hands. Okay, Vivian, so let's come back to you. I hope I've been able to clarify some things.
Yes, sir, you have.
Okay.
So let's move forward to 436.
Okay, no, but before you go, I think Cruz. Okay, great. Okay, so I can move ahead now. Ibrahim, okay, your hand came up. Okay, let me ask you to unmute. Okay, Ibrahim,
okay, sir. I wanted to ask, like, what's the purpose of the pink line?
Okay, so the pink line,
yeah.
That pink line is that's the cutoff. So the idea is this. You will see that there are certain portions of your plot, whether you use the gamma ray or use the nutrient density, where we had a hard time deciding whether they are shale or sand. And this is where this portion, let me draw a line around about it. Oops, sorry. Okay. So Ibrahim, can you see the portion I've circled? Ibrahim, are you still there? Ibrahim. Oh, he's gone. Okay, but the essence of the pink line is so that we can decide on we can pick a shale cutoff. The whole idea is everything to the left of that line is counted to be sand, while everything to the right of that line is taken to be shale. You see, because you see that the portion I've circled here, it appears to be neither sand or shale. But by the time you decide on what your cutoff value is, and now we're using 50%, I can put that portion clearly in a shale. And clearly, if you come to the neutron density, you will see that the density has trended to the right of your neutron, which also places this portion, and I'm talking about here, in. So the pink line is for you to decide on portion of your formation which it's difficult to categorize as either sand or shale. So you just, based on that cutoff, you just decide everything that falls to the left of that cutoff is sand, while those on the right are shale. Okay.
Can I make a comment?
Okay, Vivian, you can make your comment.
On the header for the density and neutron log, please, next time when you're bringing it, can you interchange it? Because it looks like
yes, I will.
I
noted. The neutron, of course, the density is supposed to be below, the neutron is supposed to be above. Same thing for gamma ray and the caliper. The caliper was supposed to be above, the gamma ray below. It didn't affect the resistivity too badly because you didn't have invasion. That's why both curves are overlying each other.
Okay, Cody has
while I was doing, and the time I was trying to switch it, but I didn't have enough time to do it.
Cody has a question.
Okay. Sorry, who has a question?
Cody.
Okay. So Cody, you can unmute.
Ibrahim, you can put your hands down.
Okay, thank you, sir.
Yes.
Yes, so please help me calculate porosity. It's not very clear in your video.
Oh, you said?
How do we calculate porosity?
Okay, for the porosity. Now, I think I mentioned also because of issues of ambiguity in the test that you should use the density for your porosity. Can you remember? I specified the density. So what you were supposed to do, so first of all, of course, most of you guys have seen it. Let's put the most likely, I think I asked for the most likely depth for the OWC. So if we take this, so the most likely depth for the OWC is here. So that's the most likely depth for the OWC. In fact, I had to take some time modifying the log so that it's going to be conspicuous, more conspicuous than before, because you see, following the resistivity alone is a little confusing. But if you go, you know that the separation for water is less than what you have for oil, and for oil is less than what you have for gas, traditionally. So this is your likely stuff. So let's go to, for the density, the formula for calculating density is the ratio between the difference of the density of the matrix minus the bulk density from the log, all over the density of the matrix minus the density of the fluid. Okay, let me write that out in text. So it's supposed to be, I'll use den for it because density matrix minus density
bulk.
Yeah, so I'll put log just for sake of explanation.
Okay.
Then you now divide this. Let me put this. You now divide it by, let me put that to go to the next line. Density matrix minus density of the fluid. No, it depends on what let's just put fluid. It depends on what you are looking at. So, Cody, are you still there? Is Cody still there? Okay, let me just continue.
Yeah.
So I think I gave you the density of materials as 2.65. I think I did. Then the density, that's for sandstone. Then the density, so you pick this from the log. For instance, you needed to calculate the porosity in the water zone. So if I pick, and your best bet is to take any portion in this where I'm cycling. You see where you had uniform, that shows you that your porosity is uniform there. So you take the density from anywhere between this portion which I've circled. So if you take the density is in red, so if you read off the density value, remember that this is 1.95, then this is I think it's 1.95 minus this. So it's 0.1. I think it's 0.1. So this is 2.05, 2.15, 2.25, 2.35, isn't it? 2.45.
Yes,
So even though it's not exactly 2.45, but I think I used 2.45. There's about 2.47 or something like that. But so even if I mean, just for this purpose, in the exam, I'll try to be as clear as possible to remove ambiguity. But don't worry, I take care of some of these little differences. So this is going to be 2.65 minus 2.45, which actually should be maybe 2. Well, let's just use 2.45. It's easier for calculation. Divided by 2.65. In this zone, the fluid content is water. So it's going to be 1.00. If you were looking for the density in the hydrocarbon zone, you're going to use 0.9. You remember I gave that. So this is going to be 0.2, I guess. 0.2 divided by 1.65, and then you can do the remaining math. That's for calculation of porosity. Don't worry, it would be more, of course, some books say you find the average between the neutron and the density, but as specified in my question, use the density log to get your porosity. So I hope that answers the question.
Okay, so there was a question you gave us, you spoke about in your slide where you said that if you are given MPISS, you get you draw a line in between.
Yes. The conventional thing is you draw a line between the neutron and the density, and you use that line as the basis for getting your porosity value. However, I know, and that's why I went this route. There are certain things that could lead to interpret differently. And that's why for this question, I specifically mentioned use the density log to get your porosity.
Okay, sir.
You see that if you check different books, there are different ways of going about these things. It's not as if. So let me take Cruz question. Let me unmute. Okay, Cruz, you can speak.
Okay. So my first question is So my first question is on the gross sand thickness. So I assume it to be net sand thickness in this case. I'm assuming that's it, right? Okay, that's just want to clarify.
Yeah. I think I have a portion on the slide where there's gross thickness, net sand, net pay. So go and check it. I will also, first when I'm setting my question, I'll put that into consideration. Of course, gross sand is there's gross thickness, there's gross rock, there's net sand, net reservoir, net pay. So go and look at that portion in the slides because of time. So okay, I think we can.
In the absence of no question, we can move ahead.
So, 2 hands raised. Let me see.
No,
It's
just
okay.
Abdul.
Abdullah, I've unmuted you.
Okay, sir. Sorry to join the class, but it's just a quick question.
Yeah.
So regarding this porosity, that's okay. So text or slides, you see that they usually usually gets the average porosity. That's from neutral and density. So in calculating your, let's say, your acidity of water, now you using is it from one of the logs, either from density or neutral or the average porosity?
Let's put it this way. I will specify. So Abdullah, just to make it clear, I will specify. What you are supposed to do actually is to find the average of the neutron and the density. Yes, in sandstone. But in some text, if there's a particular author who doesn't believe in using the neutron log at all for porosity. He prefers that the neutron is used in conjunction with the density for lithology identification and for getting the gas and gas sound. But I will specify. Let's leave it at this. That saves us of a number of issues. I will specify, and then if I don't, thank God I'll be doing the marking, so I can look at your thought process and then apportion marks appropriately. You wouldn't be penalized for things like that. I can assure you about that. Okay.
So yeah, you stopped at well logging interpretation where you said we'll be giving 2 logs.
Okay. Let me stop recording.